My dear students, in my previous video, I have explained two theorems, namely mean value theorem and Rolle's theorem. And on the basis of Rolle's theorem and mean value theorems, you have solved some problems also. In my previous video, in the topic mean value theorem, there is one correction. That is, you note down this correction please. In the previous video, a problem, that is, why the Lagrange's mean value theorem is not applicable for the function f of x equal to mod of 3x plus 1 in the interval minus 1 comma 3. This is the problem. Why Lagrange's mean value theorem is not applicable for the function f of x equal to modulus of 3x plus 1 in the interval minus 1 comma 3. But here the value for x equal to minus 1 by 3, if you substitute x equal to minus 1 by 3 here, the function becomes 0. Therefore, at x equal to minus 1 by 3, the function is not differentiable in the interval minus 1 comma 3. Therefore, the function is not applicable for Lagrange's mean value theorem. Instead of plus, I gave minus in my previous video. Instead of plus, I wrote minus here. Just note down this correction. You please correct it. It is plus. In the previous video, I gave this problem is f of x equal to modulus of 3x minus 1. That is wrong. It should be modulus of 3x plus 1. So in the place of minus, you take plus. Then only x value is minus 1 by 3 is true. So you make it this correction, please. In the previous video, correction in the previous video. Now we will go to this. In this video, series of expansion. Series of expansions. So we have expanded the function, given function f of x into a series. That is the topic in this video. Series of expansions. Series expansions of functions which are infinitely differentiable. The series expansions are possible only for the functions which are infinitely differentiable. The functions are differentiate infinite times. So if the functions are infinitely differentiable, we can apply the series of expansion. We can expand the series function as a series. First expansion is Taylor's series. Let f of x be a function infinitely differentiable at x equal to a. First, Taylor's series states that let f of x be a function infinitely differentiable. The function f of x is infinitely differentiable at x equal to a. Then f of x can be expanded as a series in an interval x minus a comma x plus a. In an open interval x minus a comma x plus a of the form. This is the form, expansion of the function f of x which is infinitely differentiable at x equal to a in an interval minus x comma a to x plus a. Then the Taylor series is f of x equal to, instead of x, we can replace f of a plus first derivative of f of x and replace x by a, that is f dash of a by 1 factorial into x minus a. Then second derivative, f double dash of x, in the place of x you replace x equal to a, f double dash of x is replaced by x equal to a is f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole cube and so on. In the nth derivative is f n dash of a divided by n factorial into x minus a the whole power n plus etc. up to infinity. This is Taylor series expansion. So f of x be a function, it is differentiable at x equal to a in an open interval x minus a to x plus a. Then the Taylor series of the form f of x is f of a plus first derivative of x, f of x is f dash of a by 1 factorial into x minus a plus second derivative of f of x, that is f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole cube etc. and so on. then nth derivative of n dash of a by n factorial x minus a the whole power n plus etc. up to infinity. This is the Taylor series expansion. And one more series is Maclaurin series. If x equal to a, then the expansion takes the form. Now, Maclaurin series. First one is Taylor series. In the place of x equal to a, it should be differentiable up to infinity. Then we can write the series in the form given. Next, Maclaurin series. Maclaurin series. See, Maclaurin series says that if x equal to, in the Taylor's expansion, if x equal to 0, if x equal to 0, that is x equal to 0, a equal to 0, sorry, if x equal to a and a is 0, if a equal to 0 in the Taylor series, the expansion series, the series becomes Maclaurin series. In the Taylor series, if you replace a equal to 0, then this Taylor series becomes Maclaurin series. Maclaurin series is if a equal to 0, then the expansion takes, this Taylor series expansion takes the form. If x equal to 0, then the expansion is f of x equal to f of 0, f of x equal to f of 0 plus f dash of 0 by 1 factorial plus f dash of 0 by 1 factorial. If you put x equal to 0, it is just x. F dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial. If you put x equal to 0, a equal to 0, this is just x square plus etc. Next time is f triple dash of 0 by 3 factorial x cube and so on plus etc. plus f n dash of 0 by n factorial into x power n plus etc. up to infinity. So, if you replace a equal to 0 in the Taylor series, it becomes Maclaurin series. The expansion is f of x equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus etc. and f n dash of 0 by n factorial into x power n etc. up to infinity. This is the Maclaurin series expansion. Using this Maclaurin series expansion, we are going to solve some problems in the exercise. So, a function can be expanded. Write the Maclaurin series expansion of the following functions. That is your exercise 7.4. Exercise 7.4. Expand e power x using Maclaurin's expansion. Using Maclaurin's expansion, expand the following function. First problem is f of x equal to e power x. You have to expand e power x using Maclaurin series. What is first derivative? F dash of x. E power x derivative is e power x only. E power x derivative is e power x only. Next, the second derivative of double dash of x. It's also e power x. What is f triple dash of x? It is also derivative of e power x is e power x. How many times you can expand differentiating? You will get again e power x. Again and again you will get e power x only. Like that. if you find fn dash of x, it's also again e power x, because the derivative of e power x is e power x. If you differentiate successively any time, it becomes e power x only. Therefore, what is f of 0? We want f of 0 from this. F of 0 is e power 0, that is equal to 1. E power 0 is 1. Next, f dash of 0, again e power 0, it is also 1. F double dash of 0, it is also e power 0, it's again 1, and so on like that. F n dash of 0 is also e power 0, that is also 1. Like that, you can find the successive differentiations up to infinite times. So, now you replace these ideas into the Maclaurin series. Maclaurin series is this. First, f of x is, what is f of x? E power x. In this expansion, we replace, after finding all these derivatives, you find f of x, f of 0, 1, e power dash of 0 is also 1. Therefore, your Maclaurin series says that f of x is e power x. It is equal to f of 0 is 1. Plus x by f dash of 0 is also 1. F dash of 0 is 1. 1 by 1 factorial into x. F double dash of 0 is 1. 1 by 2 factorial into x square. Plus f triple dash of is also 1. 1 by 3 factorial into x cube. Plus etc. plus nth derivative is 1 by n factorial into x power n plus etc. into infinity. See, this is the expansion of e power x using Maclaurin series. F of x is e power x. F dash of 0 is 1. 1 by 1 factorial into x plus 1 by 2 factorial x square plus 1 by 3 factorial x cube plus etc. 1 by n factorial x power n plus etc. up to infinity. Okay. You can write it as f of x is, you can write the Maclaurin's expansion of e power x. So Maclaurin's series Maclaurin's expansion or series of e power x is f of 0 is 1 plus x by 1 factorial, you can write it as x by 1 factorial plus x square by 2 factorial, this can be x square by 2 factorial plus x cube by 3 factorial plus etc. plus x power n by n factorial plus etc. up to infinity. This is Maclaurin series expansion of e power x. That is the first problem in the exercise 7.4. That's all for the problems. You have to find some certain number of derivatives only, some 4 times or 3 times you can differentiate, and you will substitute the values in the series, you will get the answer for the series expansion. Okay? Next problem in the exercise, find the Maclaurin series expansion of the function given function is find the Maclaurin series expansion of sin x. So, second function, f of x is sin x. So, f dash of x is, derivative of sin x is cos x, plus f double dash of x, derivative of cos x is minus sin x, plus f triple dash of x, again, derivative of minus sin x is minus derivative of sin x is cos x, plus f fourth derivative of x, Derivative of cos x is minus sin x of minus plus sin x. Minus of minus plus sin x. Again fourth derivative becomes again sin x only. Derivative of sin x is cos x derivative minus sin x derivative minus cos x derivative is cos x derivative minus sin x, therefore minus of minus sin x. Like that you find some four derivatives, and f of 0 sin 0 is 0, and f dash of 0 cos 0 1, f double dash of 0 minus sin 0 is again 0 because sin 0 is 0. F fourth derivative, f third derivative 0 minus cos 0. Cos 0 is 1, therefore minus 1. Fourth derivative sin x, sin 0 is again 0. Like that, the expansion over. Next, Maclaurin expansion of sin x is Maclaurin's expansion of sin x. F of x is sin x. First, Maclaurin's expansion of sin x is, first you write down the formula. What is f of x? F of x is f of 0 plus f dash of 0 f dash of 0 by 1 factorial into x f of 0 plus x into x. You can rewrite it as f dash of 0 f of 0 f of x is f of 0 plus x into f dash of x by 1 factorial. You write it as x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus you rewrite it as x cube by 3 factorial into f triple dash of 0 plus x power 4 by 4 factorial into f fourth derivative of 0 and so on up to infinity. Now f of x is sin x, f of 0 sin 0 0 plus x by 1 factorial into f dash of 0 1 f dash of 0 1 plus x square by 2 factorial into f double dash of 0 0 f double dash of 0 0 plus x cube by 3 factorial into f triple dash of 0 minus 1 plus x power 4 by 4 factorial into f fourth derivative of 0 is 0 and so on. So this is derivative of sin x is x by 1 factorial into 1 is x plus 0, this is 0, you need not write, minus x cube by 3 factorial plus 0, this is 0, next one is plus x power 5 by 5 factorial minus and so on. Like that, the series expansion of sin x is there. This is the expansion of sin x, x by x minus x by x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial and so on. It becomes next term is x power 6, you need not get x power 7 by 7 factorial. Minus and plus signs are alternatively occur. X cube x power plus minus like that. Sign is alternatively occurring and powers of odd powers of x only you can find. This is the expression of sin x. If you find the derivative of cos x, just you listen the problem. This is f of x is cos x. Next is cos x expansion. Derivative of cos x is minus sin x. So first derivative of cos x is minus sin x. Second derivative of minus sin x derivative cos x, therefore you get minus cos x. And the derivative of cos x derivative minus sin x is minus cos x. Third derivative cos x derivative minus sin x into minus plus sin x, and fourth derivative of sin x is again cos x, and so on. Cos x derivative minus sin, and minus cos sin, minus sin derivative minus cos derivative is cos of minus into minus plus sin x, and the derivative of sin x is cos x, and so on. Similarly, f of 0 is cos 0. Here you get cos 0, that is 1. For cos x, first derivative becomes f of 0 is 1. F dash of 0 becomes sin 0. Sin 0 becomes 0. F double dash of derivative minus cos 0. Minus cos 0, that is equal to minus 1. Okay? Cos x minus sin minus cos x, and third derivative is sin 0. It's again 0. Fourth derivative cos 0 is again 1. So in this case, Maclaurin's expression of cos x is f of x, the formula. This is cos x. F of 0 is 1. Here 1 you have. Second, x by 1 factorial into f dash of 0. F dash of 0 is 0. Here you have 0. X by 1 factorial, f dash of 0. F of 0 is 1. Next, x square by 2 factorial into f double dash of 0 minus 1. F double dash of 0 is minus 1. X cube by 3 factorial into f3 dash of 0 is 0. And f fourth derivative, x power 4 by 4 factorial into f fourth derivative of 0 is cos 0 is 1, and so on. Now replacing with for expansion of cos x is 1, this term 0, and this is minus x square by 2 factorial, and this is plus x power 4 by 4 factorial, and minus x power 6 by 6 factorial, and plus x. See, for cos x, we odd even powers of x only you have with alternative sign. But starting with 1 minus x square by 2 factorial plus x power 4 by 4 factorial, because fourth derivative of 0 is 1, and next one is fifth derivative 0, sixth derivative minus x power 6 by 6 factorial, and so on. This is the expansion of cos x. Okay, sin x, cos x and e power x I have solved in this video, and I will stop here, and we will continue the remaining problems in the next video. Thank you.